The Cosmic Tapestry, A Journey Through the Stars. Section 1, The Dawn of Wonder. Chapter 1, The Night Sky's Call. The stars have always beckoned. On a clear night, far from city lights, the Milky Way stretches across the sky like a river of light, its countless stars shimmering with secrets. For millennia, humans have gazed upward, wondering, where did the stars come from? What forged this cosmic tapestry? Our protagonist, Aria, a young astronomer with a telescope and a heart full of questions, lies on a hillside under a blanket of stars. She's not just stargazing, she's chasing the origins of the universe itself. Science tells us the universe began 13.8 billion years ago with the Big Bang, a singular event where all matter, energy, space, and time erupted from an infinitely dense point. But what does that mean? Aria imagines it, a moment when nothing became everything, when the laws of physics were born. The Big Bang wasn't an explosion into space, it was the expansion of space itself, stretching and cooling over eons. From this fiery crucible, the first particles formed, then atoms, and eventually, the stars. But the path from that primal spark to the glittering sky above her is a story of chaos, beauty, and mystery. Chapter 2, The Birth of the First Stars. Aria's telescope points to a faint patch of sky, but her mind travels back to the universe's infancy, 100 million years after the Big Bang. The cosmos was a dark, turbulent sea of hydrogen and helium, with trace amounts of lithium, the simplest elements. Gravity, the great sculptor, began to pull these gases into dense clouds. As these clouds collapsed, their cores grew hotter and denser until nuclear fusion ignited, birthing the first stars. These population 3 stars, as astronomers call them, were monsters, massive, hot, and short-lived, some 100 to 1,000 times the size of our Sun. They burned through their fuel in mere millions of years, exploding as supernovae and scattering heavier elements like carbon and oxygen into space. These elements, forged in stellar cores, are the building blocks of planets and life. Aria marvels at the thought, every atom in her body was once cooked in the heart of a star. Interesting fact, the oldest star known, HD 140283, nicknamed Methuselah, is 14.5 billion years old, older than the universe itself, a paradox that challenges our understanding of stellar ages and cosmology. Chapter 3, Galaxies Take Shape. As Aria sweeps her telescope across the Milky Way, she ponders the galaxies, vast cities of stars. About 1 billion years after the Big Bang, gravity orchestrated the formation of galaxies. Small clumps of matter merged, forming protogalaxies, which grew into the majestic spirals and ellipticals we see today. Our Milky Way, home to 100 billion stars, is a barred spiral galaxy, 100,000 light-years across, spinning through space at 828,000 kilometers per hour. But anomalies abound. The Milky Way's rotation speed suggests more mass than we can see. Enter dark matter, a mysterious substance that doesn't emit or reflect light yet exerts gravitational pull. Roughly 27% of the universe's mass energy is dark matter, and its invisible scaffolding shaped the galaxies. Aria wonders, what is dark matter? Is it exotic particles, or something stranger? Scientists are still hunting for answers with experiments like the Large Hadron Collider. Chapter 4, The Enigmatic Black Holes. Aria's thoughts drift to the heart of the Milky Way, where Sagittarius A*, a supermassive black hole 4 million times the Sun's mass, lurks. Black holes form when massive stars collapse or when dense regions of space grow uncontrollably. Their gravity is so intense that not even light can escape, making them cosmic enigmas. One anomaly fascinates Aria, the information paradox. Quantum mechanics suggests information entering a black hole should be preserved, but classical physics says it's lost forever. Stephen Hawking's work on black hole radiation hinted at a solution, but the debate rages on. Another curiosity: in 2020, astronomers detected a fast-moving object, possibly a planet, ejected from the Milky Way's central black hole, a rare survivor of its gravitational grip. Fun fact: the first image of a black hole, captured by the Event Horizon Telescope in 2019, showed the glowing ring around M87's black hole, 55 million light-years away, confirming Einstein's theory of general relativity. Chapter 5: Cosmic Anomalies and Mysteries. Aria's mind races with the universe's oddities. Take the Great Attractor, a gravitational anomaly 250 million light-years away, pulling galaxies toward it at 2 million kilometers per hour. What is it? A massive cluster of galaxies, or something stranger? Then there's the Fermi bubbles, two enormous gamma-ray emitting structures extending from the Milky Way's core, discovered in 2010. Are they remnants of ancient black hole activity or something else entirely? Another puzzle: the universe's expansion is accelerating, driven by dark energy, which makes up 68% of the cosmos. Why is it speeding up? Nobody knows. Aria imagines dark energy as a cosmic tide, pushing galaxies apart, destined to leave the universe cold and empty in trillions of years, a fate called the Big Freeze. Engaging tidbit: the Hubble Space Telescope once spotted a galaxy, GN-Z11, 13.4 billion light-years away, formed just 400 million years after the Big Bang. It's like peering into the universe's baby pictures. Chapter 6: The Star's Legacy. As dawn approaches, Aria reflects on the star's role in her existence. The carbon in her bones, the oxygen in her lungs, all forged in stellar furnaces. The universe's story is her story. But questions linger: are we alone? The Drake equation estimates the odds of communicative alien civilizations, but the Fermi Paradox asks why we haven't found them. Perhaps life is rare, or perhaps intelligent beings avoid contact, or self-destruct. Aria's telescope catches a meteor streaking across the sky, a reminder of the universe's dynamism. Stars are born, live, and die, their remnants seeding new stars and planets. The cycle continues, but the origin of it all, the Big Bang, the nature of dark matter and energy, remains elusive. Aria vows to keep searching, knowing each answer unveils new questions, like stars emerging from the cosmic dawn. The Cosmic Tapestry, a journey through the stars. Section 2: Beyond the Stars. Chapter 7: The Dance of Planets. Aria's telescope now turns toward the planets, those wanderers of the night sky. Planets form from the same cosmic nurseries as stars, disks of gas and dust swirling around young stars. In our solar system, 4.6 billion years ago, bits of dust collided and clumped, growing into rocky planets like Earth and gas giants like Jupiter. Each planet is a unique world: Mercury, scorched and cratered; Venus, a hellish greenhouse; Mars, with its ancient riverbeds hinting at lost water; and the outer giants, Jupiter and Saturn, with their turbulent atmospheres and rings. Moons add to the story. Jupiter's moon Io is a volcanic cauldron, spewing sulfur plumes due to tidal forces from its massive parent. Europa, another Jovian moon, hides a subsurface ocean beneath its icy crust, potential haven for life. Saturn's Titan, larger than Mercury, boasts lakes of methane and a thick atmosphere richer in nitrogen than Earth's. Aria ponders, could life exist in such alien seas? NASA's Dragonfly mission, set to explore Titan in 2034, may provide clues. Interesting fact, exoplanets, planets orbiting other stars, number over 5,700, with some in the habitable zone, where liquid water could exist. The TRAPPIST-1 system, 40 light-years away, has 7 Earth-sized planets, 3 in this zone, sparking dreams of alien ecosystems. Chapter 8, The Galactic Neighborhood. Aria's gaze shifts beyond the Milky Way to other galaxies. The Andromeda Galaxy, our closest spiral neighbor, is 2.5 million light-years away and on a collision course with us, set to merge in 4 billion years to form a new elliptical galaxy. Elliptical galaxies, like M87, are older, with less star formation, while irregular galaxies, like the Magellanic Clouds, are chaotic and star-rich. Galaxy clusters, like the Virgo cluster with 2,000 galaxies, are bound by gravity, forming superclusters, the largest structures in the universe. What's out there? The observable universe contains 2 trillion galaxies, each with billions of stars. Some may host civilizations, though the vast distances make contact unlikely. The wow signal, a 1977 radio burst, remains a tantalizing hint of extraterrestrial intelligence, though never repeated. Aria imagines Dyson spheres, hypothetical megastructures around stars to capture energy, as signs of advanced civilizations, but none have been confirmed. Anomaly alert, the axis of evil, a peculiar alignment of temperature fluctuations in the cosmic microwave background, suggests some galaxies may align in ways that challenge our models of cosmic isotropy. Is it a statistical fluke or a clue to deeper physics? Chapter 9, The Cosmic Web. Zooming out, Aria envisions the universe's large-scale structure, the cosmic web. Galaxies form filaments, walls, and sheets, separated by vast voids. These structures trace the distribution of dark matter, which shapes the web's architecture. The largest known structure, the Hercules Corona Borealis Great Wall, spans 10 billion light-years, containing countless galaxies. Its size defies expectations, as it seems too large to have formed within the universe's age. Dark energy complicates the picture, driving the universe's accelerating expansion. If it continues, distant galaxies will eventually vanish from view as their light can no longer reach us, leaving only the local group observable. Aria shudders at the thought of a lonely cosmos, but science offers hope. The James Webb Space Telescope, launched in 2021, peers into the universe's infancy, revealing galaxies forming just 200 million years after the Big Bang. Fun fact, the most distant galaxy observed, Jade's GS Z14-0, formed 290 million years after the Big Bang, its light traveling 13.5 billion years to reach us. Chapter 10, Life Among the Stars. Aria revisits the question of life, expanding on Chapter 6 Fermi Paradox. The Drake equation estimates thousands of communicative civilizations in the Milky Way, yet we see no evidence. Possible explanations: life is rare, intelligent life rarer, or civilization self-destruct. The Great Filter hypothesis suggests a barrier, perhaps abiogenesis or nuclear war, prevents lasting civilizations. Alternatively, advanced beings might use undetectable communication, like neutrinos or quantum signals. Exoplanet studies fuel speculation. Kepler, for 52b, dubbed Earth's cousin, orbits in its star's habitable zone, 1,400 light-years away. Could it host life? Aria dreams of biosignatures, gases like oxygen or methane in exoplanet atmospheres, detectable by future telescopes like the Extremely Large Telescope, set for completion in 2028. Chapter 11, Revisiting the Black Hole Enigma. Building on Chapter 4, Aria delves deeper into black holes. Primordial black holes, theorized to have formed in the Big Bang's chaos, could account for some dark matter. Their small size, some as light as a mountain, makes them elusive. Meanwhile, intermediate-mass black holes, like one discovered in 2020 in the Omega Centauri cluster, bridge the gap between stellar and supermassive black holes, challenging formation theories. A new anomaly, rogue black holes, wandering interstellar space, detected via gravitational microlensing in 2022. These loners may have been ejected from galactic centers or formed in isolation. Aria wonders if they could disrupt star systems, acting as cosmic nomads. Chapter 12, The Future of Cosmic Exploration. Aria reflects on humanity's quest to understand the stars, tying back to Chapter 5's anomalies. The great attractor's pull might be explained by a massive galaxy cluster, Laniakea, our cosmic home. The Fermi bubbles could be jets from Sagittarius A*'''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''''' Future missions, like the Vera C. Rubin Observatory, will map the sky in unprecedented detail, hunting for dark matter and testing dark energy models. As dawn breaks, Aria packs her telescope, inspired by the universe's vastness. The stars, planets, and galaxies are not just distant objects but pieces of a puzzle we're still solving. The universe's origin, born in the Big Bang, shaped by dark forces, remains a mystery, but each discovery brings us closer. Aria imagines future explorers, perhaps on starships, visiting alien worlds, their stories woven into the cosmic tapestry. Engaging tidbit, the Voyager 1 probe, launched in 1977, carries a golden record with sounds and images of Earth, a message for any extraterrestrial finders. It's now 24 billion kilometers away, humanity's farthest emissary. The Cosmic Tapestry, A Journey Through the Stars. Section 3, The Edge of the Known. Chapter 13, Pluto and the Kuiper Belt. Aria's telescope lingers on the faint, icy world of Pluto, once considered the ninth planet, now a dwarf planet in the Kuiper Belt. Discovered in 1930 by Clyde Tombaugh, Pluto is a frozen enigma, 5.9 billion kilometers from the Sun. NASA's New Horizons mission, which flew by in 2015, revealed a world of surprises: nitrogen ice glacier, towering water ice mountains, and a heart-shaped plain called Tombaugh Regio. Pluto's thin atmosphere, mostly nitrogen with traces of methane, collapses as it orbits farther from the Sun, freezing onto its surface. The Kuiper Belt, where Pluto resides, is a donut-shaped region beyond Neptune, stretching from 30 to 55 astronomical units, AU. It's a cosmic attic filled with icy bodies, comets, dwarf planets, and smaller objects left over from the Solar System's formation 4.6 billion years ago. Eris, Haumea, and Makemake, other dwarf planets, share this realm, each with unique traits. Haumea, for instance, is egg-shaped due to its rapid rotation, completing a spin every 4 hours. The Kuiper Belt holds perhaps 100,000 objects larger than 100 kilometers, a testament to the Solar System's chaotic youth. Interesting fact, the Kuiper Belt's total mass is surprisingly low, about 1/10 of Earth's, suggesting much of its material was ejected or incorporated into planets billions of years ago. Chapter 14, the Oort Cloud and the Solar System's Boundary. Beyond the Kuiper Belt lies the Oort Cloud, a hypothetical spherical shell of comets enveloping the Solar System, extending up to 2 light-years, halfway to Proxima Centauri, the nearest star. Proposed by Jan Oort in 1950, this cloud is the source of long-period comets, like Hale-Bopp, which take thousands or millions of years to orbit the Sun. Its outer edge marks the Solar System's gravitational boundary, where the Sun's influence wanes against the pull of the Milky Way. The Oort cloud remains unseen, as its objects are too faint and distant for current telescopes. Aria imagines it as a cosmic no-man's land, populated by trillions of icy bodies. Perturbations, perhaps from passing stars or galactic tides, can nudge these comets inward, sending them hurtling toward the Sun. An anomaly, some comets have hyperbolic orbits, suggesting they originate outside the Solar System, possibly ejected from other star systems. Fun fact, the Oort cloud's vastness means a probe would take 300 years to reach its inner edge, assuming Voyager-like speeds of 17 km per second. Chapter 15, Probes to the Cosmic Frontier. Aria reflects on the probes humanity has sent to explore beyond the Solar System's core. Voyager 1 and 2, launched in 1977, are the farthest human-made objects, now in interstellar space. Voyager 1, 24 billion kilometers away, crossed the heliopause, the boundary where the Sun's solar wind gives way to the interstellar medium, in 2012. Voyager 2 followed in 2018, providing data on the heliosphere's edge. Both carry golden records, etched with Earth sounds and images, a message for any extraterrestrial finders. New Horizons, after its Pluto flyby, explored the Kuiper Belt object Arrokoth in 2019, revealing a flattened, reddish snowman formed by gentle collisions. Pioneer 10 and 11, launched in the 1970s, also ventured beyond the planets but lost contact in the early 2000s. These probes have taught us about the Solar System's outer reaches, but their batteries are dying, and none are equipped to study interstellar space in detail. Engaging tidbit, Voyager 1 signal, now 22.5 hours old by the time it reaches Earth, is powered by a radioisotope thermoelectric generator, expected to fade by 2030, leaving the probe a silent wanderer. Chapter 16, the Interstellar Medium. Beyond the heliopause, Aria's imagination soars into the interstellar medium, ISM, the thin soup of gas, dust, and plasma between stars. The ISM is mostly hydrogen and helium, with densities as low as 1 atom per cubic centimeter in some regions. Yet it's dynamic, sculpted by stellar winds, supernovae, and magnetic fields. Voyager 1's data revealed the ISM's magnetic field is stronger than expected, aligning with the Milky Way's galactic field. The local bubble, where our solar system resides, is a 1,000 light-year wide cavity of hot, low-density gas, likely carved by ancient supernovae. Beyond it lies the local interstellar cloud, a warmer, denser patch we're passing through at 86,000 km per hour. Aria wonders about rogue planets, worlds ejected from their star systems, drifting through the ISM. In 2020, astronomers detected a possible rogue planet, OGLE 2016, BLG 1928, via microlensing, hinting at billions of such wanderers in the Milky Way. Anomaly. The Voyager probes detected unexpected tsunami waves in the ISM, shockwaves from solar flares compressing the interstellar plasma, revealing the Sun's lingering influence far beyond the heliopause. Chapter 17, What Lies Beyond? What lies beyond the known? Aria ponders the vastness of the Milky Way and beyond. Proxima Centauri, 4.24 light-years away, is the closest star, a red dwarf with a habitable zone planet, Proxima b. The Alpha Centauri system, slightly farther, hosts two Sun-like stars. Reaching these stars with current technology would take 80,000 years, but concepts like Breakthrough Starshot, a light sail probe propelled by lasers, aim to cut that to 20 years, though it remains theoretical. Farther out, the Milky Way's 100 billion stars may host countless worlds. The galactic habitable zone, a region neither too close to the chaotic galactic center nor too far for heavy elements, could be teeming with life. Beyond our galaxy, the local group's 54 galaxies, including Andromeda and the Triangulum Galaxy, stretch across 10 million light-years. The Virgo supercluster, our larger home, contains thousands of galaxies, and the Laniakea supercluster, defined in 2014, spans 520 million light-years, encompassing 100,000 galaxies. Speculation: could exotic phenomena, like wormholes or cosmic strings, exist beyond our observational reach? These theoretical shortcuts through spacetime, predicted by Einstein's relativity, remain unproven but tantalize Aria's imagination. Perhaps advanced civilizations harness such phenomena, hidden in the cosmic depths. Chapter 18, The Unseen and the Unknown. Aria confronts the limits of observation. The observable universe, 93 billion light-years across, is a mere fraction of the total, which may be infinite or finite but unbounded, like the surface of a sphere. Dark energy's relentless push ensures most galaxies will eventually redshift beyond detection, a cosmic horizon we cannot cross. The cosmic microwave background, the Big Bang's afterglow, marks the farthest we can see, 13.8 billion years ago, when the universe became transparent. What's beyond? Multiverse theories propose parallel universes with different physical laws, but they are untestable for now. The Great Void, a region 1.8 billion light-years wide with few galaxies, hints at cosmic underdensities, possibly shaped by quantum fluctuations in the early universe. Aria imagines future probes, perhaps powered by antimatter or fusion, exploring these frontiers, but for now, we're bound to Earth's telescopes and aging spacecraft. Engaging fact: the Breakthrough Listen project, scanning for alien signals since 2016, has surveyed thousands of stars but found no confirmed technosignatures, deepening the Fermi Paradox's mystery. As Aria watches the stars fade into dawn, she feels both small and connected. Pluto, the Kuiper Belt, and the interstellar void are stepping stones to the unknown. The probes we've sent are humanity's first whispers into the cosmos, but the universe's depths, its unseen galaxies, rogue worlds, and perhaps alien minds, beckon her to keep dreaming, questioning, and exploring. The Cosmic Tapestry, a Journey Through the Stars. Section 4, The Horizon of Tomorrow. Chapter 19, The Edge of Discovery. Aria sits on her hillside, the stars above her a canvas of infinite possibility. The universe, born 13.8 billion years ago in the Big Bang, has unfolded into a vast tapestry of galaxies, stars, planets, and mysteries. Yet, as she reflects on the Kuiper Belt's icy relics and the interstellar medium's whispers, she feels humanity teeters on the brink of a new era. What could we discover soon? The next decade promises revelations that could redefine our place in the cosmos. The Vera C. Rubin Observatory, set to begin operations in 2025, will map the sky with unprecedented depth, cataloging billions of galaxies and potentially detecting transient events like supernovae or even rogue planets in our galactic neighborhood. The Square Kilometre Array, a global radio telescope network, will probe the universe's first stars and galaxies, peering back to the epoch of reionization, 100 to 400 million years after the Big Bang. Aria imagines these tools unveiling new anomalies, perhaps hints of primordial black holes or unexpected signals from distant civilizations. Engaging tidbit: the Rubin Observatory could discover thousands of new Kuiper Belt objects, revealing the solar system's outer architecture and testing theories of planet formation. Chapter 20: Reaching for the Stars. To explore beyond our solar system, humanity needs breakthroughs in propulsion. Chemical rockets, like those used by Voyager and New Horizons, are too slow for interstellar travel. Proxima Centauri, 4.24 light-years away, would take 80,000 years to reach at Voyager's speed of 17 kilometers per second. Aria dreams of advanced technologies that could shrink this journey. Nuclear propulsion, such as pulsed fusion or antimatter drives, could achieve 10 to 20% of light speed, reducing the trip to Proxima Centauri to decades. NASA's Breakthrough Propulsion Physics project, though defunded in 2002, explored concepts like laser-propelled light sails, now revived by Breakthrough Starshot. This initiative aims to send tiny probes to Alpha Centauri at 20% of light speed, arriving in 20 to 30 years. Solar sails, powered by sunlight or laser arrays, are already in testing. Japan's Ikaru's mission in 2010 proved their viability. Anomaly to watch: theoretical propulsion like the Alcubierre drive, warp concept bending spacetime, remains speculative due to its need for exotic matter with negative mass. Yet, recent studies in 2024 suggest modified versions might work within known physics, sparking cautious optimism. Chapter 21: Colonizing the Cosmos. Aria envisions humanity's first steps onto alien worlds. Within our solar system, Mars is the nearest target. SpaceX's Starship, designed for reusability and large payloads, aims to land humans on Mars by the early 2030s. Autonomous rovers, like NASA's Perseverance, are already collecting samples for return in 2031, seeking signs of ancient microbial life. Permanent Martian bases could use 3D printed habitats from regolith and hydroponics for food, sustained by nuclear reactors. Beyond Mars, Jupiter's moon Europa and Saturn's moon Titan beckon. Europa's subsurface ocean, containing more water than Earth's oceans, could harbor life. The Europa Clipper, launching in 2024 and arriving in 2030, will study its ice shell and plumes. Titan's methane lakes and thick atmosphere make it a candidate for drone exploration, with NASA's Dragonfly mission landing in 2034. These moons could host outposts, using local resources like water ice for fuel and life support. Interstellar colonization is daunting but not impossible. Generation ships, self-sustaining spacecraft carrying thousands over centuries, could target habitable exoplanets like Proxima b. Alternatively, cryonics or digital consciousness uploads could preserve travelers for long journeys. Aria wonders if humanity will first send AI probes, like those proposed by Project Icarus, to scout distant systems. Fun fact: the exoplanet K2-18b, 120 light-years away, showed signs of water vapor and possibly dimethyl sulfide, a potential biosignature, in 2023 James Webb Space Telescope data, igniting debate about alien life. Chapter 22: Galactic Ambitions. To reach other galaxies, like Andromeda, 2.5 million light-years away, requires leaps beyond current science. Even at light speed, the journey would take millions of years, and faster-than-light travel remains speculative. Wormholes, hypothetical tunnels through space-time, could connect distant regions, but their stability and creation are unsolved puzzles. Quantum entanglement, while promising for instant communication in theory, cannot yet transmit usable data. Aria imagines a future where humanity joins a galactic community. The search for extraterrestrial intelligence, SETI, continues with projects like Breakthrough Listen, scanning millions of stars for technosignatures, radio signals, laser pulses, or megastructures like Dyson spheres. A 2024 study detected a repeating fast radio burst, FRB 121102, with unusual polarization, hinting at artificial origins, though natural explanations like magnetars remain likely. The discovery of a single confirmed signal would reshape humanity's worldview. Chapter 23: The Tools of Tomorrow. Scientific advances will fuel exploration. Artificial intelligence, like Aria's own curiosity embodied in algorithms, will analyze vast datasets from telescopes, identifying patterns humans might miss. Quantum computing, maturing by the 2030s, could simulate complex astrophysical processes, unlocking secrets of dark matter and dark energy. The Event Horizon Telescope's successors, like the next-generation EHT, aim to image more black holes, refining our understanding of gravity and space-time. Space-based telescopes, like the proposed Habitable Worlds Observatory, will hunt for biosignatures on exoplanets, potentially launching in the 2040s. On Earth, the Extremely Large Telescope, operational by 2028, will resolve exoplanet atmospheres in detail. Fusion energy, if achieved, could power deep space missions, with prototypes like ITER advancing toward practical use by 2050. Anomaly, the unexpected discovery of Oumuamua in 2017, the first interstellar object, with its odd cigar shape and non-cometary acceleration, sparked speculation of alien technology. Future observatories may spot more such visitors, offering clues to their origins. Chapter 24: A Universe of Wonder. As the stars fade into dawn, Aria's heart swells with wonder. The universe is not just a collection of stars, planets, and galaxies, it's a story of creation, evolution, and possibility. Soon, we may confirm life on Europa or Mars, detect alien signals, or map the cosmic web's farthest reaches. Advances in propulsion, AI, and telescopes will carry humanity to new frontiers, perhaps to Proxima b or beyond, where we might find mirrors of Earth or something entirely alien. Yet, the deepest mystery remains: why does the universe exist at all? The fine-tuned constants of physics, gravity's strength, the proton's mass, seem perfectly balanced for stars, planets, and life. Is this chance, a multiverse quirk, or something purposeful? Aria doesn't know, but the questions themselves are a call to explore. She imagines future generations walking on alien soils, their ships soaring through interstellar voids, their minds linked to a cosmic network of knowledge. The universe, she realizes, is not just out there, it's within us, in the stardust of our bodies and the curiosity of our souls. As Aria packs her telescope, she whispers to the stars, "We're coming." The Cosmic Tapestry, vast and unfinished, awaits its next thread. Engaging fact, the proposed Louvre telescope, if funded, could image Earth-like planets in reflected light, potentially revealing continents, oceans, or even city lights on alien worlds by the 2050s. Keep looking up, keep wondering, and keep exploring. The stars are just the beginning. The journey has only just begun.